and welcome Yale University, in particular Martin Lovell and Timothy Thompson. You should switch on your camera. Yeah, and the presentation is, I think it's a good fit. It's also about a mapping from MARC, but with a more specific use case. And so I'm happy to start the talk, or to let you start the talk to find more about it.
Okay, great. Thank you, Jakob, and good morning, good afternoon, or good evening to everyone, depending on where you may be. Thanks for attending the session and to the conference organizers for the opportunity. So today we'll be presenting work on a project that's part of a multi-year effort at Yale University in the United States to create a cross-collections discovery environment designed using the principles of linked open data. Yale is building a new platform called LUX, or Lux if you want to be precise, meaning light from the Latin motto of the university. LUX aggregates descriptive metadata from the catalogs of Yale's 4 main collecting units: the Art Gallery, the Center for British Art, the University Library, and the Peabody Museum of Natural History. The LUX platform is being built using the linked art profile of the CIDOC-CRM ontology as its common data model. Each unit has developed its own crosswalk from its local domain standard to the linked art model. Our focus today will be on the work that was done to document and implement a fairly comprehensive yet functional crosswalk to convert the Yale Library's MARC 21 catalog records to linked art in JSON-LD. I'll discuss the definition of the crosswalk, and Martin will present the technical details of how it was implemented. Just in passing, I'll mention at the 2021 LD4 conference, I presented with Rob Sanderson about the background of Yale's Cross Collections Discovery Initiative. I won't go into further detail about it today, but I'll refer anyone who's interested to the recording of that presentation. A beta version of the LUX platform was released a little over a month ago, and I'd like to share a very quick demo of the platform with you. So let me share my screen quickly. A moment, bear with me. Okay. Can you see my screen, Martin? Sorry, Martin, would you be able to bring Lux up? I think I have having a browser issue unless I can open it in Firefox.
I'm not on the VPN right now.
Okay. Well, apologies for the hiccup. We may come back to that if time allows at the end. So I'll move on in the interest of time. So how do we get from MARC 21 to linked art JSON-LD? To document the crosswalk, a set of modular specifications was created using the Darwin Information Typing Architecture, or DITA, which is an XML standard published by OASIS, the Organization for the Advancement of Structured Information Standards. The DITA standard was designed for documentation and technical writing and is based on the idea of topics. A topic is a discrete unit of information that can stand on its own. DITA topics are organized into a logical structure using another type of document called a map, which can be thought of as a table of contents. DITA is well supported by tooling such as the DITA Open Toolkit, which makes it easy to convert the XML source to a variety of output formats, including Markdown, which was the primary format used for the LUX crosswalk. To create and manage the crosswalk specifications, the Oxygen XML editor was used. Oxygen includes robust support for DITA, including graphical user interfaces for authoring structured documents using DITA elements and attributes. This slide shows an example outline of the MARC to linked art specification suite in Oxygen's DITA Maps Manager. I'll discuss, There are currently 133 separate documents in the specification suite. The specifications are divided between top-level entities and descriptive content. The top-level entities are further divided into record-level entities and related entities. Record-level entities are the linked art equivalents of MARC bibliographic and holdings records. They represent the objects held by a collecting unit and the works or intellectual content that is carried by those objects. Related entities are the equivalents of MARC authority records and represent the conceptual, social, and geographical context that produced both objects and works. A data pipeline has been developed for LUX that ingests each unit's transformed data and enriches the related entities with information from external linked data sources such as Wikidata, the Getty Vocabularies, and the Library of Congress Linked Data Service. Descriptive content, for its part, represents the textual or typed data that fleshes out the description of a record-level entity. One of the main challenges of discovery across collections is integrating the very different kinds of content coming from each collecting unit, from museums, different kinds of museums, from the libraries. To organize the diverse kinds of objects and content brought together in LUX, a small taxonomy was developed called the supertype taxonomy, which categorizes record-level resources by content type and format. Of course, the library collection is largely books, journals, manuscripts, and archives, but an effort was also made to highlight other kinds of materials such as paintings and collages. There are a few of those as well. And each specification in the crosswalk has a basic three-part structure, as on this slide, which shows the mapping for the collage category. There's a source data section that includes an embedded snippet of YAML code, followed by a series of processing steps that include instructions for implementing the transformation. For the supertype specifications, those steps are also expressed as YAML and encode a set of conditions for extracting data from different parts of a MARC record. Finally, there's an output section encoded as linked art JSON-LD, which can be used for testing the result of the transformation. So one of the key features of this crosswalk is that it is mapping from document to document. So from MARC as a document structure to JSON-LD as a document structure rather than from MARC to triples. So that in some ways simplifies things a little bit. Apart from the supertype class specifications, most of the other specifications have steps that are narrative in format and provide information to contextualize the metadata mapping. Individual steps and substeps are presented in textual form, and each step can have its own result section to illustrate what shape the output should take. So I'll now hand it over to Martin to explain the technical framework used to implement the specifications.
Hi, thanks, Tim. I'm Martin Lovell. I'm a software developer, so I'll talk about the technical implementation and some of the issues we ran into and how we worked around them. So this is just to contrast with what we were doing. This is our typical transformation where we take a holdings in a bibliographic record and we might convert it to a single record. And usually we're simplifying the data and the facets and things like that are handled by the system using it. And we can also sometimes use just a single configuration file to do all the mappings. And this linked data, and Lux projects started out that way, but we soon realized it needed to be different. So this is our basic mapping. It's a holding and a bibliographic record. They get translated into some linked Dart entity, and there's a relationship between them. And like Tim said, we have a lot of our data is the bibliographic information will be a linguistic object, and the holding will be a human-made object. And it gets a little bit more complicated based on some of the supertype taxonomy and things like that, where we'll have different types of objects, and the relationship's a little bit different. And these cross arrows are kind of important because what we found is that sometimes data that would end up in the linked art for the holdings would really be in the bibliographic record. So we had to have some way to get that data over into that JSON as we were parsing the holding record. And then, of course, as we're going through the bibliographic and the holding information, where we run into persons and places and groups and identifiers and things like that. And so we'll mint an ID for those and either find them in our system or create a new one and find it the next time we encounter it. So this is a little bit about how we process the data. And so what we did, oops, sorry again, we process the data by setting up these transformers, which are really just pieces of code that the data goes through as it gets transformed into this linked Dart. And at the end, we ended up with about 73 bib transformers now and about 70 holdings transformers. And of those bib transformers, about 32 were super types. And this is the case where we had the super type information would affect the linked data for the holding. And so what we did for those is as the data was going through, we add a little bit of metadata to the database. So then later when we're parsing the MARC for the holding, we can use that data to affect the linked Dart mapping. And here's just a picture. So we get the bib and we create a top level entity, which is a resolvable entity. And we have an object that represents the JSON. We sort of just bounce it down these transformers, and each transformer typically will either add some JSON to the main record for the bib or the holding, or it might look for and create, if it doesn't find a new entity to relate to one of these objects. So this is just a diagram showing that with those new entities sort of getting created as the main entities go through these transformers. And then at the end of all of it, we get the main record for the bib and the main record for the holding. Sometimes we'll have multiple bibs per holding. And at this point, we know what type they are and what their relationship is, and we create that and save them to the database. So this is a little bit about how we save things to the database. So during that process, any top level entity, any resolvable entity that gets created in its JSON gets saved to the database. And during that process, it goes through these filters or processes that either that manipulate the data or store some of the data. This is one of them that we use. It's called processing the IDs, and we use that primarily because it turned out as we were iterating over mappings, and especially when there were huge, big structural changes, it was easier for us to just clear out all the top level entities and recreate everything. But that caused some trouble for people downstream who were using our data because all our IDs would change. What we do is when we're creating a new entity, we look up in this other table to see if we have created that sometime in the past and use that ID. And then if it's not in that table, when we store it and mint a new ID, we store it there. So the next time we can use that same UUID. And then there's another process that goes through which extracts relationships. And I'll talk a little bit more about these later, but it goes through this object that represents a JSON and finds all the relationships from this top level entity to any other top level entity. And it'll store the path of relationships to it. And this comes in really handy when you want to see relationships coming into an object. And I'll show you examples of that later. And then we have the activity stream. So if it's a new object, we add a create to the activity stream. And if it's had JSON before and it's changed, we add an update to the activity stream. This is a little bit about just the URLs to request the data. One thing we found early on was that it was good to have a URL to request by BibID in our source system. And this comes in handy, like, you know, in Tim's documentation, he would often put a BibID or a MARC or a holding ID for us to test. And so as we were developing, we could easily get right to that record without extracting all the data and assigning UUIDs. So that came in handy. And then our typical IDs are just /node and a UUID, and that's the way all our entities are served up. And then this is the way that we can get relationships going into this entity. And again, that comes in really handy when we're diagnosing problems with the mappings and seeing what's happening. So here's a little bit about the incoming relationships. So we had the regular request and we add on that /relationships, and it returns this list of all the relationships coming into this object. So the object is the same for all these entries, but these are different subjects that relate to it somehow. And you can see it gives you the full path to this other relationship, which comes in handy. So you don't have to keep following different paths to get to it. You get right to it. And then if I clicked on this link here to see what linked to it, you would see that this is the actual link data in the relationships. And that's how we generate the path to this item here. And then something about normalizing and merging the data. This is really common, and I thought it'd be good to just show it in code. So what we typically do, this isn't a function where we create a new person, is we'll take the value from the MARC and normalize it, which means taking out diacritics, normalizing white space, taking out some of the punctuation, and we can tell it to leave some punctuation. And then we go in and look in the database and see if we have that person with the normalized value. And if we do, you know, we check to see if we have that person or not. And if we don't have the person, we just create a new person. And whether that person's new or not, we do the same thing with it to relate it to the record that we're processing. And a little bit about database schemas. This is our schema now. It's really simple. We have the main object, which is our top level entity, and the JSON's really just stored in this text field here. This is that metadata we can store to use later. And these are our relationships, a really simple table. And then our record IDs, we just store off to the side so we can reuse them after we delete these tables. And the activity stream just sort of stands by itself. And this was our original plan. And whoops, sorry. Our original plan was to just create more like a triple-based system where every single entity was a JSON object. Every JSON object became an entity in the database, and every single relationship was stored in the database. So we didn't store any JSON, and this was pretty nice for a little while. But we were running out of time, and we couldn't iterate fast enough, and we only really got about 10% of our data into the system that way, and it was taking, you know, weeks to just get in that much. So we had to come up with another solution, and that's why we came up with this solution of just storing the JSON in the tables. And at first, we kind of lost a lot because we lost that way to get the incoming relationships. But we added that little table on the side to be able to do that, and it worked well. And now we're able to ingest our full set of data in about 48 hours, which gives us a really fast turnaround time so we can look at it quickly. And just some statistics to end with. This might look like a lot of data to some people, might not look to some, but to us this was a lot of data. We had about 13 million holdings records, about 12 million bibliographic records. And we also ingest archive space records, which I didn't really talk about. And we came up with about 50 million top level entities, almost 2 million relationships between them, and you know, about 24 pieces of metadata and about 50 million entries in the activity stream. And that's it for the slides. So I guess we're ready to answer questions.
Thank you very much. Okay, we have time for some questions. First, there was some confusion because you use a lot of different technologies. At least for my part, it was a confusion. So could you quickly summarize? You use Gita XML, you use YAML code, you use config JSON, produce JSON, and then somehow it ends up in RDF. How does it? Well, what are the core, most important parts? How do they belong together?
Right. So DITA is the documentation framework. It's provides the structure for the text of each specification. So a specification typically will specify all of the MARC fields needed to construct a person entity, for example, and output it in linked art JSON-LD. So the DITA XML is the document framework. That's what's used for authoring the text of the specifications. Within each specification, there's a kind of a header section which specifies source fields from MARC to be where data should be extracted. And that's specified as embedded YAML, just a snippet of YAML code. The idea was that parts of the specifications could be pulled out and processed computationally, but I'm not sure to what extent that actually happened, but that was kind of the original thought. And then the output or result for each step within a specification is an embedded snippet of JSON-LD, which conforms to the linked art profile of CIDOC-CRM. So it's basically the DITA XML with some other code bits embedded in it.
Okay, so XML just for documentation. You could also have been used Markdown or some other thing, and the definitions are YAML. And then there's a related question. This is YAML code. Is this your creations, for instance, the addresses, like which field to use or which part of the leader? Does it follow some standard, or is it your creation?
So the YAML code was based on the Martin. You might help me with the name. It's the it's used in the Traject Ruby library. It's a convention for specifying MARC fields. So there is a convention that it's some of that is based on. Some of it is just internal convention, but the YAML bit is really just to specify these are the MARC fields and subfields and indicators, fixed fields that should be targeted for extraction. But the actual algorithms or instructions are expressed for most of the specifications in text in steps that are defined in DITA XML. The super type specifications, which are our taxonomy mappings, those are a bit more structured. So those are all YAML for the steps. And that was an ad hoc. That YAML is just ad hoc.
Okay, thanks. Then a different question. Did you find a need for any of the RDA LRM concept like work, expression, manifestation, item?
Yeah, so linked art does or could accommodate something like that, perhaps more on the level of BibFrame, where you have a two-part distinction between content and carrier. Right now we haven't, or no merging or no clustering of work entities has been performed. So that's something that's being actively investigated right now. We have defined transformations for MARC uniform titles, which are work-like entities or have been transformed into a work-like entity. But there are issues with those because they don't always perform a clustering function. Sometimes a MARC record has a uniform title, a 130 field, but it doesn't actually, it's a singleton, it's only on one record, so it doesn't really cluster anything, and it creates a lot of orphan records in the data set. So So actual clustering is something that's being investigated right now, but it could be accommodated.
Yeah. Okay, then there was there was interest in the activity stream, but yeah, it had already been answered in the chat that it will be made public. It's not at the moment, but in the future. And then two last questions. When you reconcile entities based on labels, is it done by machine or by person? How do you deal with homonyms and synonyms?
Right. So right now, it's not it's an automated process which has just a very minimal level of normalization to avoid some of the most egregious, discrepancies. So so a missing comma in a name string will be normalized so that those two name strings will match. But we have had some other projects. We have a project which is helping to clean up and reconcile in a semi-automated way some of our most common names in the library catalog, and that's working with student employees to work through a spreadsheet that's been generated to verify particularly name strings that are not qualified by, say, a birth or death date, where there may be, there may be a real need for disambiguation, where there may be multiple identities that are reflected by the same name string. So that's a process that has been initiated, but there's obviously a lot more work to do there, and it hasn't been, we're not doing anything sophisticated there yet.
Yeah, we all know without identifiers we are lost. There's one last quick question before we proceed to the next talk. Do archive-based records get different transformations than BIP records?
Yeah, it's much different. And right now, we store the same data, and we have the same, some piece of, we share a lot of code between the two to generate the JSON, but they're really two separate sets of data right now and transform much differently.
Okay, so there's interest in this transformation too, but this can be followed in the chat and in the code repository. So I thank again for this talk, and we go